Good morning all. So this is the question bank from VTU for engineering visualization subject. Now we are moving on to the second section, that is projection of lines. So in this first problem given, a line PQ has its end dash mm and above HP and dash mm in front of it. So from here onwards I need to take the values in order to do the problem, because they have not mentioned any values here. So randomly I will choose the values in order to solve the problem. Okay, so these problems I am doing based on the request of the students. So make sure you all share this problem to all the needy students, and it will be helpful for them. Okay, so subscribe for the channel and hit on the bell icon for the latest notifications and share it to maximum students. Okay, first I have drawn an XY line, and now I have to consider the end point distance. End A having distance, I will be defining some reference distance I will be considering. Okay, so 20 mm above HP, and because they are not given any kind of distance here, and 30 mm in front of VP. Okay, so that is for the line P. Okay, and similarly for end B they have given dash mm below HP and dash mm below behind VP. So again we should consider the length here for them, for the end Q also. Here I will consider some distance here. $30 mm above HP, and behind VP means it is for the top view. So behind VP means it is for the top view. So here I will consider some distance. Uh, 45 mm in front of VP, behind VP. Okay, so these are the locus distances. Now the end projector distance also we have to define here. So that telling in the question, first I will take end point distance. Okay, for the end points P and P dash. That is A dash. So we can mention it as, because it is a confusion in the question. They are mentioning PQ and then they are mentioning NDA and B. I will be considering as a line AB only. Okay, in order to avoid the confusion. So that is A dash and A. So here the end projector distance between the end projector of the lines given, I will take randomly the length here. I will take 60. Okay, and I will draw the projection lines upward and downward. So by doing this, so we are getting the end points B dash and B. So by joining them we get the upper end length. Okay, this is your point B and this is B dash. Okay, now we join with the thick line. You can show the end projector distance 60 mm, which I have been assumed. Okay, now take thick line 0.50 to connect A dash and B dash. That is your first upper end length, and the second end upper end length from A to B. Okay, these two are upper end lengths, and these are different in each other. You see that they don't have the same length. Now by rotating these lengths, you can get the true lengths. So measure from A dash to B dash and cut the arc, and then you have to project a line vertically downward. So project till the end of B here. Okay, this is where we are getting the B2. Join it from here to here. Okay, you can see that is what the thin line for the true length. Okay, now the same way we rotate this AB end, and we rotate this upper end length. Okay, now we draw a straight line projecting upward from this end. Okay, now you join here from here to here. So this is your B1 dash. Okay, so we have completed both true lengths and apparent lengths. Now I am going to measure these true length distances and angles as per the question given. So measure, you can see the true lengths will be same in both the top and front view. Okay, that's what the concept. Okay, and measure the angles. Okay, measure the angles. Okay guys, it takes so much effort in order to solve these problems. So I request all the students to share these problems within your friend circle to the maximum students. The students may be studying in different colleges. You can send it to them. Okay, so it takes a lot of effort in order to solve these problems. It's not easy. So by randomly selecting the lengths, I'm trying to solve it because these problems are not exist in your solution book. Okay, by taking some random values and doing it, it's not easy. So I request every student to share these problems within your friend circle, or if your friends are there in different colleges, share to them also. Okay, so that completes the problem. Okay, so you can mention true length will be same here. Okay, true length now I'm writing. So the true length we are getting the same, that is 62.65 mm. Okay, and true length angles, true angles. So as per the question, true angles, that is 9 degree in front view and 14 degree in top view. So this completes the problem, first problem, projection of lines. Now we move on to the problem number second. Problem number 2. You can see a line PQ dash mm long makes an angle dash degree to HP and dash degree to VP. The end P is dash mm in front of VP and dash mm VP. Okay, the line here it is, we should consider the true length here. Okay, first I will be drawing an XY line by taking thickness 0.25 mm. Can write XY VP HP. So from projection of lines we can consider first quadrant. Okay, now I will be considering the locus line for the end points. Okay, the end P is will be considering the using the okay, I will be giving the end distance here. So 10 mm above HP and other distance I will give 20 mm in front of AP. Okay, now here in this problem they have given the true length with the angle of inclination. First I will take a reference end points. Okay, now it will be easy for me to construct it. So here line PQ means that is P dash and P I should mention. Okay, angle of inclination I should mention. Here true length we should consider. So the length I will consider, that is 80 mm and angle of inclination to HP 30 degree. Okay, I will measure both length and angle. In the same way I will be taking in the below XY line, length will be 80 mm and angle will consider minus 45 degree. Okay, now with respect to these end lines, so find out the length and the angle here. Okay, so here with respect to this end points we consider another locus lines here. This is P dash Q1 dash and this is PQ2. So again go to line, select the dashed lines here. Okay. Now using these two lengths we can construct the upper end lengths. So just project the straight line vertically downward. Then go to arc by center. Measure the distance from here to here and cut the arc. Okay, go to trim command and trim it this part. Go to line and select the thick line here, 0.50 mm thickness you can consider. Okay, this is your PQ, this is your end PQ, and same way I'll be projecting upward vertically, that is from Q to end, above Q2 end, and go to arc by center, measure the length from here to here and cut the arc. Okay, now I can join this with a thick line, okay, from P dash to Q dash. This is your Q dash. So we have constructed both upper end length and two lengths. Now angles I am going to measure. That's what apparent angle, and this is what the apparent angle. Okay, so this completes the problem. Now we move on to the problem number 3. A plane and elevation of line PQ dash mm long measures dash and dash respectively. That is, first they have given the PQ line means it is nothing but true length, and then measures means it is nothing but upper end length, the top view and front view we should consider. Next, end P distance they have given above HP and in front of VP. Determine its projection, determine the true inclinations with HP and VP. In this problem we should consider both true length and the upper end lengths. Okay, by taking those true length and upper end lengths we should construct the problem here. Okay. So in order to solve these problems, guys, I'm telling you seriously, it takes a lot of effort. So I'm requesting from you that you should share these videos to your respective classmates so that they can be benefited from this. Okay, first we will construct an XY line with thickness 0.25 mm and mention XY VPHP. So in this problem we should consider both true length and upper end length. So here the end point distance I will consider first using offset command. 20 mm above HP I will consider and 30 mm in front of VP. So there are two locus lines I am considering. I will change these continuous lines into dashed lines. Okay. Now here first I will consider the true lengths. So here true length they are not given, and the upper end, using this upper end length we should construct the true length. So measures dash mm and that means here with the help of the upper end length we should proceed the problem, because we don't know how much length at which the true length it is falling, because we don't know the angles also. So I'll be using the upper end lengths to construct the true length here. So I'll consider the first upper end length as 75 mm. Okay, upper end length in top view. Now, so that's what 75 upper end length. Now now we construct the true length from this end. I'll consider the true length for 80 mm. Okay, type 80. So here actually I should consider this arc by center instead of the line. Okay, go to arc by center, and here from this end select the radius 80 mm and cut the arc. So this gives the True length 80 mm. Okay. The same way we do it for the. So at the end of it, we draw the locus lines here. Can mention that this is P dash and Q1 dash, because this is an true length. Q1 dash. Okay, angles also you can mention. This is true length, angle of inclination in front view. Now again, so I'll be drawing another apparent length. I consider another apparent length. Okay, apparent length in front view we consider. So I'll consider the length of 70, and I will draw vertically straight line downward. Okay, so go to arc by center. This is 65. Okay, 65 and 75. There are two apparent lengths. So go to true length. As we know that, so I'll considering the true length as 80 mm. So cut the arc for 80 mm length. Okay, just by extending this straight line, so you can get the exact point here. I think I have not drawn a end point line here. Okay, just check it. Okay, yes, that is what the mistake. So I'll be considering the first end point length here for that P point. Then after that again I will redraw. Okay, so that we get the exact reference end point. So again go to arc by center. So from that end point consider a length of 80 mm and cut the arc. Okay, now we can see, so we're getting the exact end points. So now you connect from this end point to the, so we're getting the true length here. Okay, so we're getting the true lengths. By using this true lengths, we can get the apparent lengths here. Already we have drawn the apparent lengths of 65 and 75. Okay, using this we can cut the arcs, so it will be easy. So with respect to the end of this another true length, I'll be constructing another locus line. Go to arc by center and measure this length and cut the arc. So by cutting the arc we get the upper end length here now. So from this end point P dash, so this is what your P dash Q dash. Okay, same way do it for the bottom end. So this is what the 75 mm we should consider. So already I've drawn a straight line. Okay, so cut the arc. So now join the upper end length with the thick line of 0.50 mm. Okay, so this is what we constructed both upper end lengths and top views. Now we have to find out the lengths. So you can mention here. So this is P, this is PQ2, that's what true length, and this is PQ, this is true length. Now we have to mention the angles. So true length in this problem I have considered 80 mm. Upper end length in front view I have considered 65. 65. Same way, apparent length in top view I have considered 75 mm. Actually 75 mm we should consider. So now we measure the apparent angles also. Okay. Okay, this completes the problem number 3. Okay, now we move on to the problem number 4. Okay, you can see here line AB dash mm long is inclined at dash to HP and dash to VP. Its middle point C is dash mm above the HP and dash mm in front of VP. So it is nothing but middle point problem in projection of lines. That means first we construct this midpoint. From there I will be proceeding. That is first I am going to write that midpoint C. From there I will be considering the length. So in this problem I will consider the true length as 80 mm, angle of inclination to HP 30 degree and angle of inclination to VP 45 degree. Okay. So draw the XY line by taking thickness 0.25 mm. Mention XY, VP, HP. Okay, now for the midpoint, I'll be considering a distance here 30 mm above HP and 45 mm in front of VP. Okay, this is where we should mention that C point. That's what the midpoint here. So from this midpoint, I'll be drawing the true length. Okay, true length I'll be drawing it. So from this midpoint end, length 40 and angle 30. So later I will be extending this to 80. Okay, the other side. So this is 40. So I'll be extending this line. See here, parallel, you get the parallel symbol. Okay, length will be 40 and angle will be 150. That is what. Okay, you have drawn one true length for a length of 80 mm and angle 30 degree. Convention, this is A dash, this is B1 dash, I'll consider this as B1 dash, and this is C1 dash. Okay, in the same way in the HP plane also I'll draw the midpoint line. So for showing the angle, okay, I'll draw a smaller line from that C1 dash, horizontal line. Okay, yes, from this end. Zoom in and show 30 degrees. In the same way, the same procedure I am going to follow in the HP plane also. So take a line and give the length 40, and here angle I'll consider that is minus 45, that is 45 degree. Okay, so measure the angle, measure the length and extend this line using parallel line command. So that is, we should extend this line for a length of 40 mm. Angle is again same 135 degree. Okay, okay, mention the namings here also. So this is the end point A, other end point we have B2, and this is C2. So you can see we get only the with the straight line we have the midpoint. Okay, so now, so all to with respect to all these reference endpoints. Okay, first we'll mention the angle, then we should mention the locus lines here. Okay, so I'll be going to line and mentioning the locus lines here for all these endpoints. For endpoint of B1 dash, C1 dash, so everywhere we should mention these locus lines. Here also you can see that there is a dotted line appears. Just moving the cursor over that point and just you drag it, you'll get that dashed line. This is where you have to construct the locus line. Okay. Now using this true lens, we should construct the upper end lens. Okay. So that means we have to. So we should not rotate this true length. Sorry. So we have to consider we should rotate only the upper end lens. I think this is wrong here. I'm going to redo it again here. I think this step is not correct. Okay, so like this we should do it. Now rotating it by rotating the upper end length. So you're getting A dash and B dash. In the same way we can mention A and B. So that completes the problem. Okay, now we move on to the next problem, that is problem number 5. So line PQ has its end P in HP and dash M in front of AP. Its front view is inclined at x degree to xy and has a length of dash. The other end Q is in VP to other. So here in this problem they have given the upper end length in front view. So using that upper end length and angle, so we should proceed here in this problem. Draw XY VP HP. So one end HP and P in HP means it is P dash, and in front of AP means the T end distance. So using the top set command, so in front of AP means in the HP we should give distance 20 mm. Okay. This is what for P dash and P. P dash should be written on the XY line and P. You can see its front view is inclined at dash degree to XY and has a length. So that means we should consider the upper end length and angle here to construct it. So here the length I'll consider 65 and angle 30 degree for this upper end length. You can mention Q dash, length you mention and angle also mention. Now you draw with respect to the end of the line, the locus line. Okay. the other end Q is in VP. Draw the projections and find out its true inclinations with HP and VP. By rotating this apparent length and then projecting downward, so we can get the true length here. So with respect to endpoint, we know that both the apparent lengths are falling in a straight line. So by using that concept, I'm constructing the apparent length in top view also. So both the views get constructed here. Now by rotating this apparent lengths, we can construct the true length now. So select P dash, Q dash. Cut the arc. Now you join this point, you will get the true length. Now we have to connect it. Join from P to this end point. This is PQ2. Okay. The same way we will be rotating this PQ. Go to arc by center. Select this length PQ and cut the arc, and now project it upward to get the true length. From here to here you can join. This is PQ1 dash. Okay, Q1 dash. Now I can mention the dimensions here and mention the angles. Find out its true inclinations with HP and VP. Okay, so true angle of inclinations we have to find out. This is the first angle of inclination to true length, and this is the second angle of inclination to the second true length. So now we can mention the true angle of inclinations. True length angles. True length, it is 68.01 mm. So that's what we have to find out in the question. And then true angles in front view is 29 degree, in top view it is 17 degree. And true angles in front view it is 29 degree. So you can subscribe for the channel and hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. Thank you for watching the video. Thank you all. And